My name is Peter Stott, and I'm at the Met Office Hadley Centre, as well as at the University of Exeter. And in this presentation, I'm going to address the question, how have climate and hazardous weather changed already in the UK and elsewhere? Climate is changing. Across the globe, temperatures are increasing, rainfall patterns are changing, and snow and ice are retreating. Weather is changing too across the world, including the UK. Heat waves are becoming more frequent and more extreme, threatening people's health and welfare, and heavy rainstorms are becoming more intense, leading to more flooding and loss of lives and livelihoods. What is the evidence for this, and what does this mean for the future? If you want to find out for yourself how climate is changing, there's been a rapid growth in the last few years of information sources providing the latest data on climate that you can go and investigate for yourself. For example, at the Met Office, we have recently instigated a climate dashboard, an online resource that provides up-to-date information about the latest measurements. I'm going to go through a few of the graphs provided on the climate dashboard to show you some aspects of our changing global climate. If you go to this link, you can explore more for yourself. This graph shows how global average temperatures have been changing since the mid-19th century. Temperatures are now more than 1 degree Celsius warmer than they were back in pre-industrial times. This can be seen in 7 different data sets, including the HAD-QT dataset shown in the black line that we at the Met Office produce in collaboration with the University of East Anglia, and which is based on weather station measurements over land and measurements of seawater temperature taken over the oceans. You can see from this graph how well the 7 data sets agree with each other, despite taking very different approaches in their analysis procedures. This graph, also taken from the Met Office Climate Dashboard, shows how carbon dioxide concentrations have increased as a result of fossil fuel burning. From pre-industrial levels of about 280 parts per million, concentrations are now well over 400 parts per million, a rate of increase of over 2 parts per million per year that shows no sign of abating. Concentrations of other greenhouse gases in the atmosphere are also increasing. This graph shows how nitrous oxide concentrations are steadily rising, as indeed are also methane concentrations. The result of adding to the natural greenhouse gas effect and warming the atmosphere and oceans is that snow and ice are melting at a terrific rate. Arctic sea ice is undergoing a dramatic decline, and with continued emissions, is set to have disappeared completely within the next few decades, drawing the annual minimum in September. This plot shows that as well as a general reduction, there has also been a marked change in the seasonal cycle of Arctic sea ice, which you can see there towards the end of the 2000s. This is one aspect of our changing climate that is not yet fully understood. It is important to remember that if we are going to successfully tackle climate change, it is essential that we understand better exactly how our climate is changing now through continually improving our observational network, our climate models, and our fundamental understanding of the processes at work. A good example of where greater understanding is urgently needed is related to the Antarctic. For many years, as this graph shows, since about 1980, Antarctic sea ice was not declining, but was very gradually increasing. And you must remember in this context that Antarctica is a cold continent surrounded by ocean, and the amount of sea ice cover is a delicate balance between warming of the ocean atmosphere, snowfall, and dynamical changes in how the ice behaves. But a few years ago, and surprisingly, Antarctic sea ice extent saw a dramatic drop off to the lowest levels seen in the record, which you can see there in the latter part, in the middle of the 2010s. More research still needs to be done to understand exactly what is going on. But just like the Arctic, it is vital that the climate in the polar region is well monitored over the coming months and years. The latest research, including this article in Nature that was published on the 24th of September this year, does show clearly that there are big global risks associated with warming in Antarctica. This paper by Julius Garber and colleagues from the Potsdam Institute for Climate Impact Research shows that substantial melting of the Antarctic ice sheet is underway, melting that could lead to over 2 meters of sea level rise at 2 degrees global warming above pre-industrial levels. Moreover, this is melting that is irreversible due to the long-term partial collapse of the West Antarctic ice sheet. At high levels of warming, the risks of irreversible melting are even higher, with very large committed levels of sea level rise that would be impossible to halt, even if greenhouse gas emissions are eliminated entirely. These results come from the development of a fully dynamic ice sheet model and show how improved modelling and observations are able to substantially enhance understanding of the risks involved with climate change. As the authors conclude, if the Paris Agreement to keep global warming to well below 2 degrees Celsius is not met, Antarctica's long-term contribution to sea level will dramatically increase and exceed that of all other sources. So what is happening in the UK? Here too, we have new sources of information that can help you see how climate is changing for yourself. At the Met Office, we provide the annual State of the UK Climate Report, providing the latest weather data and putting it into the context of the changing climate. This is published each year in a special issue of the International Journal of Climatology, and this infographic shows a summary of the latest findings. 2019 saw the highest record temperature in the UK that was recorded at 38.7 degrees, a temperature of 38.7 degrees recorded at Cambridge Botanic Gardens on the 25th of July. It also saw the highest winter temperature recorded, which was 21.2 degrees Celsius at Kew Gardens on the 26th of February. This is part of a record of a warming climate in the UK. All of the top 10 warmest years on record have occurred since 2002, and temperatures are now about a degree warmer than they were in pre-industrial times. 2019 also saw above average rainfall, with significant flooding events, including flooding in Yorkshire in November 2019, an event to which I will return later in this presentation. If you delve deeper into the report, you can see how temperatures are changing seasonally. In the summer, which is shown by the purple line, the third line down on that graph, there has been a marked warming in UK temperatures since the late 19th century, albeit with some cooling during the 1950s and 60s. This was a period during which there was a lot of air pollution from coal fires, which shut out sunlight and abated regional warming temporarily. Since the early 1970s, summer temperatures in the UK and indeed throughout Europe have been increasing rapidly, causing a dramatic increase in the risk of damaging heat waves. In 2004, I published a study into the European heatwave of 2003, which is estimated to have killed about 70,000 people throughout the continent. By comparing observations with model simulations, we estimated that human-induced climate change had very likely at least doubled the risk of temperatures that hot. We followed this up with a further study a decade later, led by my colleague Nikos Christidis, which showed how the risk of such heat waves had continued to increase. Now, extreme heat wave events that would occur twice a century in the early 2000s were now expected to occur about twice a decade. These are examples of event attribution studies that are linking individual extreme weather events to our changing climate and are demonstrating just how significantly our extreme weather is being affected by human-induced greenhouse gas emissions. As I said, in 2019, we saw a record temperature in the UK of 38.7 degrees Celsius recorded at Cambridge Botanic Gardens, which raised in our minds the question of how likely it was that we could start seeing temperatures of 40 degrees or more in the coming years. We published a study to look at this earlier this year in the journal Nature Communications, and this infographic summarizes the results. It shows how the probabilities of such temperatures expressed as an expected return time between such events is increasing rapidly. Without human-induced climate change, such extremes are effectively impossible. But with climate change, such temperatures could be observed somewhere in the UK, most likely in the southeast of England, once every 3 or 4 years, with continued emissions of greenhouse gases. Given our current lack of preparedness in the UK in coping with such extremes, in our housing stock, hospitals and care homes, it is another example of how important it is to take account not just of the mean changes in climate, but also the increasing risks of extreme weather. As well as increasing heat waves, this plot from the latest UK State of the Climate report shows how the frequency of very heavy rainfall is increasing in the UK. The plot shows the number of weather stations across the country recording more than 50 millimetres of rain in a single day. As you can see, there is a lot of variation from year to year, but a clear trend is seen over the last 60 years, with an almost 50% increase since 1960. Earlier, I mentioned flooding in Yorkshire in November 2019. The worst of the flooding occurred after very heavy 24-hour rainfall totals were seen of up to 82 millimetres that were falling on already saturated ground. It led to at least one fatality, at least 500 properties flooded, and 1,200 households evacuated. The picture on the left shows an example of a flooded road in Yorkshire, and the map on the right shows the rainfall that fell across the country, showing this region in that part of the country with very high rainfall totals. In fact, over a month's worth of rain falling in that region over just the one day. In a paper submitted to the journal Weather and Climate Extremes, led by my colleague Daniel Cottrell, we have investigated how the risk of very heavy rainfall days is increasing in the UK. Looking at the Hadley Centre gridded rainfall dataset, which goes back throughout the 20th century, we find in the left plot that there has been about a 60% increase since 1900 in the incidence of days with daily rainfall of more than 50 millimetres. Projecting that forward using high-resolution simulations made for the UK Climate Projections Programme, we find that with continued emissions, there could be about another 85% increase in the incidence of such heavy rainfall days from now until the end of this century. This increasing frequency will dramatically increase flood risk and pose massive challenges to local authorities seeking to protect their communities from the devastating consequences of household inundation. Like the example of the risk of irreversible melting of the Antarctic Ice Sheet, these analyses of UK heat waves and heavy rainfall events underline the importance of the Paris Agreement to keep global warming to well below 2 degrees Celsius. Even with rapid reductions in emissions, there will be an increase in the frequency and intensity of extreme weather events to which we'll need to become much more resilient. To sum up, the climate is changing globally and in the UK substantially and in alarming ways. Recent heat waves, floods, and also storms and fires show us how vulnerable our societies are to weather events that were once very rare, but which are now becoming much more common. Increasingly, scientists are able to better monitor these changes and project how they will change in future. But further scientific understanding is urgently needed if we're going to properly address the climate challenge. Crucially, we need to better quantify the current and future risks of humanity's climate-altering pollution. It isn't just the Antarctic Ice Sheet where improved monitoring, modelling and process understanding is, as it needs to, rapidly advancing. It is happening throughout the global climate system, and increasingly so in the UK, as we advance our capabilities to better quantify weather and climate risks.